Hi everyone, welcome back to Technoboom. I'm Ankita Shah, currently working as an AI engineer at Fractal Analytics. In today's video, we are diving into something super important for anyone who is preparing for Cognizant interviews. I'll be sharing actual SQL questions that were asked and explaining the key concepts like joins, views, clauses, and functions, all with easy examples and visual demos. This session will give you a quick, complete revision of SQL. So grab a notebook, stay till the end, and let's crack it together. Let's begin. So let's see the basic concepts. What is database? A database is a collection of organized data that can be easily accessed, managed, and updated. For example, a college database that stores students' details, marks, attendance, etc. What is DBMS or a database management system? A database management system is software that interacts with users, applications, and the database itself to capture and analyze data. SQL is the language, or we can say standard query language, which is used to interact with a relational database. So, what can you do with SQL? We can basically do CRUD operations. C means create, R means read, U means update, D means delete. Now, what is a table in SQL? A table is a collection of rows and columns, and each of the tables represent a real world entity. For example, employee and student. So here we are demonstrating a table of employee. Here you can see the employee ID, which is unique for each and every employee. So that's why we call this employee ID is a primary key. Then employee name, then department, then salary. Then types of DBMS. There are mainly two types of DBMS. First is relational and the second one is non-relational DBMS. Relational DBMS or RDBMS. Here the data is stored in form of tables or rows and columns, and it uses SQL for data operations, and it is best suited for structured data and applications like banking, ERP, etc. On the other hand, if we see the non-relational DBMS, then the data is stored in non-tabular format, basically in form of JSONs like key value pairs, documents, graphs, or columns. And in case of non-relational DBMS, it does not require SQL. It uses JSON-like or custom query formats. The examples of RDBMS are MySQL, Oracle, Postgres, SQL Server, SQLite, etc. And the examples of non-relational DBMS are MongoDB, Cassandra, etc. So here we will see how to create a table. For example, suppose I want to create this type of table. Then we can see the first column is employee ID. And this employee ID is unique for each and every employee. So we can easily declare it as a primary key. So basically the syntax is create table, then the table name. In my case, the table name is employees. And I will declare each and every column. The first column name is employee ID. Then the type, the data type of that column, which is int. And since it is a primary key, because each and every values are unique, so I'm declaring as a primary key. Then comma, then next column employee name, which is varchar. It's like a string. So in SQL we declare it as a varchar, and within the parenthesis it is the size or the maximum size of that particular variable. And we can also declare the department, and for salary the data type is E. And we can demonstrate a retrieval process from that employees table. For example, if we want to retrieve the employees with salary greater than 28,000, then we will use that select command. Select star from employees where salary greater than 28,000. It will retrieve the employees who are having the salary greater than 28,000. Basically, except this person's data, everyone else's data will come up. Then we will see the SQL command categories, which are DTL, DQL, DML, DCL, TCL. DTL is data definition language, DQL is data query language, DML is data manipulation language, and TCL is transaction control language. Here in this picture, you can see the DTL commands. DTL commands are create, drop, alter, truncate, rename. So DTL is a short form for data definition language, which deals with database schemas and descriptions of how the data should reside in the database. The commands that are inside the DTL is create, drop, alter, truncate, rename. Then comes data manipulation language or DML. It deals with data manipulation and includes most common SQL statements such as select, insert, update, delete, etc. And it is used to store, modify, retrieve, delete, and update data in a database. Then comes TCL. TCL is a short name for data control language, which acts as an access specifier to the database. And two commands that are within this TCL is grant and revoke. Grant actually grants permission to the user for running DML commands on the table, and revoke actually revokes permission to the user for running DML. And the DQL command or data query language command is select. And then TCL. TCL is a short form for transactional control language, which acts as a manager for all types of transactional data and transactions. Some of the commands of TCL are rollback, commit, save point, etc. Next, we will discuss about SQL constraints. There are some constraints that are available and their descriptions are shown here. First one is not null. It tells that we can store null values in a column. Then unique. It ensures that all values in a column are unique. Then primary key. It uniquely identifies each row in the table. If a field in a table has primary key, then the field will not be able to contain any null values, as well as the rows should have only unique values for this key. That's why it is written as not null plus unique. That means the value should not be null and each of the values should be unique. And then foreign key. A foreign key is a field which can uniquely identify each row in another table. Then check. It can limit the values allowed in a column. Using the check constraint, we can specify a condition for a field which can be satisfied at the time of entering values for this field. Then default. Default is the constraint which is used to provide a default values for the fields. That is, if at the time of entering new records in the table, if the user does not specify any values for these fields, then the default value will be assigned to them. Here you can see the diagram. Suppose we are creating a table employees. The employee ID, as we have already discussed, it should be the primary key because each and every employees are unique, are having the unique ID. So that's why, and the employee name, each of the person should have a name. So that's why employee name should not be null. And then age. And here we are including a check constraint to check that the age should be greater than or equals to 18. That means if the user types any person's age below 18, then it will be discarded. So we are filtering the values of or we are filtering the data of that person which are having a certain age. Then email, each of the person's email should be unique. So we have written email varchar 100 unique. Then date ID in salary decimal 10,2 default 25,000. If for some of the persons salary is not specified, then as a default value we can give them 25,000. Then foreign key. Foreign key depth ID references department's depth ID. So we are having another table department which is having the same the common column which is depth ID, and so using that common column we are just linking the two tables. So this thing is called foreign key because for that department table the depth ID is the primary key. Then let's say SQL where clause. The where clause is used to filter records that meet a specified condition. For example, we can see the table employees, and suppose we want to retrieve the employees from this table who belongs to Delhi. Then we can simply write select name city from employees where using this where clause city equals to Delhi within inverted commas because this thing is a string. So we will get the data containing only the column name and city because we are retrieving only these two columns. And you can see that these two data will show up because we are filtering the data using that where clause. Then let's see the SQL order by clause. Order by clause is actually used to sort the result in ascending or descending order. If we want to sort the result in ascending order, then we can simply write ASC. If we want to sort it in descending order, then we can simply write DESC. So suppose this is the table that we originally have, and I'm writing this query select name, comma salary from employees, order by salary DESC. That means I want to order the person's data by their salary in descending order. So you can see that the data will show up like this, and the salary is ordered by descending salary ranges. Then SQL limit clause. It is actually used to restrict the number of rows returned by a query. Suppose I want to retrieve only the top two highest paid employees. Then we can write select name, comma salary from employees, order by salary DESC because we want to retrieve it in descending order so that the highest two will come up at the top, and limit two. That means we only want two highest salaries from the table. So this is the table that we will get. Then SQL group by clause. It is used to group rows with the same values in specified columns, often with aggregate functions. Group by clause is actually used often with the aggregate functions. Aggregate functions are like count, sum, mean, max. These are the functions called aggregate functions. We'll be seeing these aggregate functions more briefly in upcoming slides. So here we can write this query select department, comma count star as num employees. As clause is used just to give a particular name of that column. Suppose we don't write as num employees here, then in output this column will show up like this count. It will be written as count here. But since we want to give a certain name to that column other than this count star, so that's why we have just renamed it with that num employees. From employees group by department. So suppose here you can see that only 2% are there from HR department and 2% are there from IT department and 1% is there from finance department. You can see from the original data that there are 2 persons in HR department. So exactly that thing came up here. So we can use this group by clause just to group the data together when the particular column contains duplicates, so that we can, if it don't have duplicate, then also we will get a result like finance. Here you can see that only one data is there using that finance department, so that's why the count is 1. So it just groups the data together. Then SQL having clause. The having clause is used to filter the result of the group by statement based on the specified conditions. It actually works like the where clause, but when we use group by function, group by clause, then when we use group by statement, then we can use having clause, not the where clause. So here you can see that table is here, and suppose we want to know the sum of the salaries, then we can write this query: select department comma sum of salary as total salary from employees, and we are grouping them by department. Okay, then after that, suppose I want only that sum of salaries which are greater than 50,000. Then we can't write where here because we have used group by statement. So in case of that, where we are using that group by statement, we have to use having only. So that's why we are writing having sum of salary greater than 50,000. So this is one of the things that are very crucial. You have to focus here that where we are using group by, then we have to use having, not where clause. Now we will be seeing where versus having clause. Where clause filters row before groups are aggregated, but having clause filters group after the aggregation process. Where clause can be used without the group by clause, but having clause can only be used when the group by clause is there. And where clause cannot contain aggregate function, but having clause should contain aggregate function. Where clause is used before the group by clause, and having clause is used after the group by clause. Where clause is used with single row function like upper, lower, etc. Having clause is used with multiple row function like sum, count, etc. Then introduction to SQL joins. There are various types of joins. Inner join, which returns only the matching rows from the table, from both the tables. Here you can see from the diagram, suppose the table 1 and table 2 is there, and only the common columns of that table 1 and table 2 will be returned. And left join returns all the row from the left table plus matched rows from the right table. You can see here in this picture all the rows from the left table and the common rows from both the tables will be shown as an output in case of left join. And for right join, you can see in the picture or the whole right table along with the common part of both of the table will be returned. Full join is like the whole thing. It returns all rows where when there is a match in either left or right table. So full join is not there in MySQL, but we can use it using union also. Self join, it joins a table with itself. Cross join actually returns the Cartesian product of both the tables. So in case of cross join, the Cartesian product of the table will be returned. That means every row of table 1 with every row of table 2. Let's see the self join more briefly. Suppose here this is the data. So if you analyze the first row, then the employee ID of Alice is 1 and her manager ID is null. Let's say the second row, Bob's employee ID is 2 and his manager ID is 1. So that means Bob's manager is Alice. So in case of that, we will be using self join where we have to join the table with itself. So we will virtually consider that we have that employee table with a copy of another employee table. So suppose let's consider that we have two same tables there and we have to join with itself. Join that particular employee table with a copy of that employee table. So self join query to find employees who are more than their manager. So let's do that. Select e.name as employee, m.name as manager, e.salary as employee salary, m.salary as manager salary. From employees e, join employees m on e.manager ID equals to m.employee ID. So let's see here that we are considering this whole table as two tables. Okay, so suppose we have two tables, employee and another table as the same name, employees. And for the first table, we are considering that employee ID as the primary key, and for the second table, we are considering that the manager ID is the unique ID. So using that manager ID, we are joining them together. And let's see what has been retrieved. This is the table that has been retrieved from there. Then let's see SQL aggregate functions. The functions are count, sum, average, max, min. Count actually returns the number of rows. Sum returns the total sum of a numeric column. Average returns the average value of a numeric column. Max returns the maximum value of a column, and similarly min returns the minimum value in a column. Suppose we have this employee table, and let's see these operations, how we can implement this operation in that table. Suppose we want the total salary of all employees. Then select sum of salary as total salary from employees. So it will be returned as returned with this number, and the column name will be total salary, because using this as we are renaming that particular thing, that particular sum of salary thing, we are renaming it using the total salary. And similarly, if we want to return the average salary, then select AVJ, which stands for AVG, which stands for average salary as average salary from employees, and it will return this thing. Similarly, maximum and minimum salary, select max salary as highest, min salary as lowest from employees. It will show you the maximum and minimum in the same line. Then count of employees. Select count star from total employees from employees. It will show you the number of employees that are present in that table. Then MySQL functions overview. MySQL provides several built-in functions to perform operations on data. These are commonly used for string manipulation, mathematical calculations, date and time operations, and aggregate calculations. This last point, aggregate calculations, we have already discussed in the last slide. Let's see the string functions. The string functions are upper, which converts the text into upper forms or upper cases. Similarly, lower, which does the opposite thing. It converts all the text into lower cases. Then length. Select length name from employees. So it returns the length of the name. For example, here the length will be 1, 2, 3, 4, 5. So the length of Alice is 5, then 3, then 7, like this. Concat. Concat actually concatenates or combines the name, or like whatever column we pass through, it will concatenate the whole thing. Select concat name, comma, we can insert a hyphen as we are considering it as a string, then we have to insert a inverted comma there, comma department from employees. So it will be like Alice hyphen HR. The interviewer can ask you that suppose we have two columns, first name and last name. We have to generate another column, full name, where the first name and the last name will be concatenated together. So this is one of the important question that often Cognizant interviewer asks. Then date functions. Functions are car date, which returns the current date. Then year function retrieves the particular year from the whole date. For example, suppose we pass this thing, this joining date column, then it will retrieve the 2021 and 2022, like that. Month, it actually retrieves the month from a particular date. Date D, it actually returns the difference between the two dates. Car date, comma joining date. Suppose we want to retrieve the date difference from today's date to the date that that particular person has joined. Then we will use that date diff function. Then also we have some mathematical functions as well, ABS, which returns the absolute value of a particular number. That means select ABS within parentheses. If we have minus 500, it will give you the mod value. Then round, it actually rounds up the number. Then seal. Seal is actually returns the ceiling value. See, in the opposite way, floor, it actually returns the floor value of a particular number. Then mod, it returns the mod value. Then MySQL Views. A view is a virtual table based on the result of an SQL query. It does not store data physically but displays data from one or more tables. For example, suppose we have this employees table and I want to create a view for HR department. So we will write create view HR employees as select name salary from employees where department equals to HR. And if we want to see what are the data that are included in the view HR, then we will simply write select start from HR employees. So these are the data that will be included in this view. So there is a popular question that often Cognizant interviewer asks, which is table versus view in MySQL. Table actually physically stores the data, but view is a virtual table based on a select query. And storage. Table occupies physical memory in the database, but view does not occupy space. The data is fetched dynamically. And table has faster access since data is stored, and view is slightly slower because it depends on the underlying query complexity. As it is not stored, it is a virtual table, so that's why it takes much time to get accessed. Security, full table access required, and in case of view, it can hide sensitive columns useful for restricted access. And dependency, table is independent object, but view depends on the base table. Let's say the difference between delete, drop, and truncate. Delete is used to remove a specific record from a table, a specific record or some more records from a table. It can be used with a where clause to specify which are the rows that we want to delete. It's a DML command or data manipulation language command. It's lower compared to truncate because it logs each row deletion, and the deleted data can be rolled back if the transaction is not committed. Drop, it is used to delete an entire table, the structure of the table, the database or other databases objects like views, indexes, etc. It's a DTL command. It removes the structure itself, not just the data. It cannot be rolled back, but back once executed unless there is a backup. Truncate, it used to remove all the rows from a table. It's a DTL command like drop. It does not log individual rows deletions, making it faster than delete. It can be rolled back in some databases. It depends on the DBMS. Thank you.